Hi guys, this is Sashank Falagati again, and I'd like to take this time to show you some of my landscape level of detail techniques that I've developed here at the Guildhall. The LOD goals in any project is to try to get an even visual quality for as little performance as possible. You do this by maximizing and evenly distributing the number of triangles available on the screen in screen space, and you can do this by implementing a level of detail. The idea here is that I have an island here of height map values data is organized into patches, where each patch is a separate vertex buffer. And then I am rendering those vertex buffers with different levels of detail, higher level of detail for patches closer to the camera and lower level of detail for patches farther away. So I have a pretty good visual quality for stable performance. The patches are selected for their level of detail based upon the proximity to the camera, and for this I'm using a logarithmic function where since each level of detail is a power of 2 in vertex count, I use a logarithm to determine what is the appropriate level of detail to get an even number of triangles on the screen. In addition, certain patches, as you can see the one here, have a little bit of a bias to have a higher level of detail. And you can also see the same thing over here on the cliff side. They have a little bit higher level of detail than the neighbors surrounding it, regardless of the camera state, because they intrinsically have more variation in their terrain. And I do that. I calculate this intrinsic level of detail using a simple root mean square function kind of algorithm that allows me to do that. The only other thing that's interesting in this demonstration is, let me freeze the LOD here, is the seam stitching between patches. So you can see here that in order to stitch patches of various numbers of triangles from one patch to another, here you can see that there are squares of, say, length 1, and here there are squares of, say, length 2. And in the middle there are these triangle kind of things that match the two of them together. Otherwise, what I would have is at this point right here, the very center of my screen, a T intersection, which is not good, where a single vertex meets the side of another polygon, and because of the changing height values, that would create seams that include gaps in the terrain. You can see that the level of detail is pretty much organized upon the intrinsic value of the island and then the proximity of the camera. In addition to this, I have the entire island organized into a quad tree, and so what I'm doing is when I render, I actually am doing a recursive rendering call with frustum culling enabled, so I can face over here and then turn around, and the entire bounding box of the lower left quadrant is eliminated from logarithmically eliminated from the scene, making the rendering operation of O log n. That's pretty much it for the landscape, and I hope you like it. You can see that some of the level of detail you can see hopefully popping in and out as I come in closer from the camera and go farther away. I hope you like this. Thank you very much.